Thank you for joining us today for our ETRAGE webinar series. We typically host different topics within the design and manufacturing industry twice a month. You can find future webinars at etrage.com under events. A few housekeeping items before we get started. Everyone is muted. If you have a question, please use the Q&A icon. If we are not able to answer your question during today's session, we will follow up with you after. A recording of this webinar will be available on our ETRAGE YouTube channel later this week. So today's agenda, we will do an overview of ETRAGE as a software development company, talk about Creo NC, and then the majority of this will turn over to our live demo on the feature function benefits. Again, if you have any questions, use that Q&A and we will answer those as we can. I am Sinead Kimbrell. I started in the PTC channel in 2013. A big chunk of my professional life has been dedicated to adult education. And with me today presenting the Creo NC is Sean Feringer. With 25 plus years of Creo experience, he is a certified Creo instructor. He has a grand variety of knowledge, but is very highly knowledgeable about tool and die in the manufacturing side. ETRAGE is a software development company. We have been a PTC technology partner for over 20 years. Our mission and goal is to help companies integrate their enterprise system to make sure that anyone within their company or their vendors can access data and make sure that that data can flow easily between systems without duplication. We are experts in automating processes and allowing that data to flow within the manufacturing space. We offer software and services. Some of our key software products include ETRAGE Viewer, which is its own viewing system that allows companies to publish through our ETRAGE publisher data from Windchill and share it across the organization so that everyone has access to the same data. We also have a document management system that allows you to track revisions of documents and set up approval processes outside of CAD documents, as well as a bulk loader that allows you to increase at a faster speed data loading into Windchill or data exporting from Windchill. Some of our key services include new software development. That is what we do. We love talking to customers and figuring out how to solve their needs through our ETRAGE software. We also can host your Windchill environment and provide support, customizations, upgrades, and migrations. We also have training on various PTC, Creo, and Windchill topics. You can see some of our customers, both here in the United States as well as globally. We do focus on design and manufacturing companies of various sizes. Again, our goal is to help them internally and externally share their data, automate processes, and make sure they're bridging the gap between systems. And we do this so that they can really complete their digital thread. On the training side, we do offer private and public classes. Those public classes can be found on etrage.com, where we have a schedule. For private classes, we do have standard curriculum that we can help tailor for your end user's specific needs to meet your company's standards. And we can also work with you to customize and make curriculum from scratch that really focuses on your internal processes and standards. Additionally, we offer an online e-learning platform that is self-paced, and we can offer mentoring on various topics that maybe you can't find a standard class for. So today, talking about Creo NC. As you may know, PTC does have a powerful and comprehensive NC package focusing on manufacturing engineers and machinists. Sean will speak to that capability. Do note that ETRAGE does offer consulting, so if you are looking for some help around your Creo NC processes, needing post-processors, mentoring for machinists, please reach out. We'd love to help you. And with that, I will turn this over to Sean.
Hello, everyone. Thank you for joining us today for a Creo NC demo. We're going to go ahead and take a look at Creo NC today in just an overarching sense and some of its key core strengths, if you will, and capabilities. And again, thank you for your participation. So here we have a Creo NC file open, and it's in its kind of a completed state. We're going to take a few minutes to kind of take this apart and talk about some of the key features and benefits those features provide for utilizing the Creo NC product, in conjunction with Creo design or as a standalone in a manufacturing environment, if you will. Creo NC is obviously stood up on the backside of Creo Parametric, if you will. This is a standard Creo Parametric. It's just a punch widget that we have here today that we're going to take a look at. This punch widget exists on what we call a whoops, I've got an instance open. My apologies. So I'll have to open the generic here. So we'll open up that. So this object exists on what we call a family table. As we see here, we have a tabular setup that is used on the design side to create different, in this case, 4 different iterations of this widget, having slightly different dimensional and, geometry configurations based on the values of that table. The reason that this is significant is because we can do the programming in Creo essentially one time and essentially speak to all of these 4 objects with one input. That's just one of the many benefits that Creo NC enjoys, being connected as intimately as it is to the Creo Parametric product. But we'll be jumping back and forth between this part a little bit because, in fact, we're going to watch changes on this part deploy into the Creo NC environment, if you will. But this is our Creo Parametric object that we're going to work today. It's just been created as a demo for this purpose. It contains a handful of different Creo Parametric features that are, as I mentioned, manipulated by the tabular information in the family table. So we'll kind of keep this in the background, if you will, a little bit. I'm going to close that particular instance of the object that I had opened, and we're going to go back to our Creo NC file here. Now, as I mentioned, we see here, and I'll just kind of show this real quickly as a first part of what we look at today, and then we'll kind of get more intimate about Creo NC in and of itself. But as I mentioned, we have 4 versions of that part on the table, if you will, and that allows us to, intimately switch these things out quickly and easily and keep all of this programming that you see here. So we have a bunch of these cuts already established on this object. You can see here we have some mill surfaces and stuff shown here on our part. And these were used to create different cuts and things to that effect on the part. Those surfaces can be hidden and shown and things to that effect, much like you would work with any other NC or design product, if you will. But in this case, what we're looking to show is that, okay, hey, I've got this punch 2 version of this object up here right now. And if we just come down, for instance, and look at the center drill path, and I'm going to turn that on and play this and set it up. And we see, okay, here's where the center drill is, drilling on these parts, and it's drilling those whole locations that we see there. If we were to swap this object out as I mentioned, for one of those others on the table. So I'm just going to go select one of those other table objects. We'll select the generic in this case, which wouldn't typically be, a workflow, but we'll do it anyway. And now we see we've swapped that back over to the other iteration of this part, and we've moved these holes and these dimensions somewhat by doing that. But all of the machining is still connected to that. So when I come in here and I play the center drill, it's still very much connected to those parts and to that, geometry that we worked with there. So if we were to jump back to our punch part, and this is the part that we now have in the NC side, and I'm going to go ahead and open up our punch 1 iteration here, and we see that doesn't have the dowel pins in it. So let's go find another one that does have the dowel pins, so it's a little easier to see what happens here. Okay, there we go. So this one does have the dowel pins in it. So let's go ahead and manipulate the dowel pin position in this file. So this might represent a typical scenario of an engineering change that somebody is making with Creo Parametric, and we're subsequently moving these dowel pin holes around here, and I'm just moving these pin locations that represent these dowels and kind of reattaching them. And that might represent an engineering change that somebody does inside of a Creo Parametric model. Now, because we have this linked in and we have this kind of awesome associativity between Creo Parametric modeling and Creo NC stuff, when I jump back into the Creo NC part now, our punch assembly, and I go ahead and I bring up that part, and we'll go ahead and regenerate that. Now we see that, my center drill subsequently follows that new geometry automatically. So this is the essence of one of the biggest benefits of doing everything in the same house, as I like to say. We do the design in Creo, we do the NC in Creo, everything is linked in, everything is associative. We can subsequently make changes to the object in design, propagate those changes into NC, and not be reprogramming and starting over and going through extensive rounds of double checking and things to that effect to, in fact, make sure that what we expected and in fact was what happened. So, the power of being able to do that can't really be overstated. It's a very significant part of, the benefits that you get from working in a connected, universe like that. So that's what this is all, that's where the rubber meets the road. That's what this is all stood up on. That's probably the most important and most significant thing that people enjoy in their design and NC LinkedIn connections when we're using both, we're using a PTC product to address both of those issues, both design and manufacturing. Now, we understand that it's all connected and it's all associative, and I can work on families of parts, and I can just come in here and I can right click on this and swap this out for another one of those, and I don't have to redo all the programming like we saw and things to that effect. Very, very powerful stuff. But let's have a look at, some of the things that Creo NC in and of itself does. So here inside of Creo NC, it's a tree, and you build out your cuts and things to that effect like you kind of would in most any modern NC product. But we'll talk about a few of these significant, things that Creo NC does. So like if I'm to come in here and here we have our part, and I've just rolled back in time, which is one of the nice features that Creo NC and the design side provide, is the ability to roll back in time and kind of sequentially step through the iterations of what you've done and how you've built what you built. So here in this case, we've got a face mill, and I'll just activate that, play that, put that on the screen. And of course, you can play these things through. And then we have a simulation product that's tied into this called ModuleWorks. Excuse me, pardon me. That actually allows us to, kind of like in a real-time sense, watch the material being removed. In a more advanced playback, I should say. And we also have here inside of Creo NC the ability to work with this green part that you see, which in this case represents what is referred to as my workpiece. Now, when we make cuts to the workpiece, one of the benefits here is that will progressively be understood by Creo NC as we move along as what we would generically refer to as a stock modeling context. So in this case, I did a material removal, and that material removal is taking off from my workpiece everything that this face mill cut off. So now my workpiece is the same height as the top of my part, you know, because that's been trimmed off. So now we'll go step down through these cuts here. So we have some different cuts we can look at. So here's a sketch that I've made to create what we refer to as a trajectory, which is a big fancy word to refer to path. So we're saying, hey, this is the path. You know, I'm going to have this you know, oval shaped path that goes around the part here. And then this is the cut that is associated with that path. And this is one of the ways we can do that. So we're going to kind of come in and rough this material off in a kind of a biting in profiling sense and rough down the, you know, the punch to that level, you know, using that as our path. That's one way we can do this. We can simply sketch these curves or select a curve on the edge of a model, for instance, the curve I'm highlighting now, and we could use that as a path to drive a tool. We can sketch those paths. We can pick those paths off the model. We have a lot of flexibility for that. These types of trajectory path-based cuts are available in 2 through 5 axis. Okay, so everybody in, you know, all things NC pretty much does some form of profiling too. So here we have the equivalent type of cut as a profiling operation, and we'll kind of watch this go through now, and we kind of see the same type of stuff happening here, but it's based on a profiling operation instead of a path, or as we said here, trajectory-based operation to take that same material off. Now, what's driving that profile cut is this surface. And this is a unique, very powerful feature of Creo NC, is the ability to simply create this surface, copying a piece of the design model underneath. You can see from the zebra striping that these things are in fact dimensionally coincident. And the ability to copy this surface and then subsequently pull this surface up to my workpiece so that the cut doesn't think or understand anything having to do with this secondary boss that exists on my part. That's not what I'm trying to do right now. I just want to rough the primary shape from the bottom up. I am in this stage of operation not really looking to, you know, get into the intimacy of cutting into these fancy details on the top, but I want that boss to be complete from, you know, the top down or the bottom up, however you want to look at that. In order to drive that when my geometry isn't that, because as we see looking at the geometry here, it doesn't have that shape. If I told it to just profile these surfaces of the punch that we see here, it would create a cut that starts up here and would be kind of a little disconnected, and then it would eventually catch up to the full circumference where it's continuous, and then it would, you know, proceed with the cut. But the ability to create this surface quickly and easily and copy it and just pull it on up to our workpiece allows me to pull in this profile cut that we saw and drive it from that surface so that I don't have to get into a cutter path that gets involved in the top of the part up here in a way that I'm not looking to in this stage of the cutting operation. So it's very powerful to have the features of being able to create on the fly geometry that's not linked into the actual model. So we have this surface here on the model and it is associative to the model, but if I were to actually go open this object, that surface isn't there. That surface doesn't negatively impact the design group. It's not something they have to hide on a drawing or something they have to interact with in any way, shape, or form. The surface simply doesn't exist for the design group. It only exists here in my space inside of Creo NC. And this provides for a lot of strength for me to manipulate an object by adding some surfacing to it to influence, you know, the cutting of that object in the right, you know, or in the desired way, shall we say. So after that's been completed, we could go do a material removal cut again. And when I pull this material removal cut into the timeline, as I just did, we can see now that, yep, now it's clipped the model again. The face mill clipped it off on the top on this surface, and the material removal that we just did referenced this profile cut and subsequently clipped it off down to where the radius intersects tangent on the shape of our punch. Now we have another surface that I'm going to hide. So we look down here and yeah, this is the kind of stuff that becomes a little bit problematic, right? So we have this big chunk of material here in our part that we still need to knock off. And we've got a tangent radius that's coming up off of the bottom of it. So it's nice and powerful here inside of Creo NC to be able to, create a surface just using that edge, that tangent edge of that radius where that exists, and then subsequently drive another cut up against that surface. So now we're using a great big face mill type of tool here, and we're going to go in and we're going to cut everything off, take a one big pass cut, everything off right up to that surface. And see, we can grab the tool here and position it on our cutter path and then kind of see the nature of it and how it's working up against our surface and, the context positionally of our tool in the NC space. So now we've kind of cut that off as well. We've done a path to cut around that. So, hey, let's go ahead and do another removal on that. And now we see that we have knocked our object down to a very a very clean, roughed state. We have this step of green material that we've got to deal with here that cuts out for a radius. We see that we've got a little bit of material left on the outside of our punch. We've taken it down to the top surface here, and we've really set this up in a way now that we're really ready to kind of rough off, clean, and finish the punch itself as far as that goes. Now, of course, Creo NC affords us the ability to do 3-axis tool pass and things to that effect. But before we get to that, we're probably going to come and finish the outside of the punch. And that's what we're looking at here is a cut that comes in and takes this to size. And, because we saw that we have a little extra material on there, we can see right there. So, and then we can finish the top, finish the boss radius here as we see. So that cut's going to be a little bit more involving. Bear with me. It's got to kind of regen that calculation. And here we see the cuts coming in and cleaning out and creating that radius with a much larger tool. And the interest of that was played pretty fast. I'm going to do that again. So in the interest of being able to rough down to that face and keep a clean surface finish on the bottom and things, now we've got this big tool that we can come up in here with and just spin up that radius tangent in the bottom and get that part of it cleaned off as well. So then we might set up some cutting to rough off the top of the part. Here in this case, we're doing the roughing to take down the top of our object here where we know this extra material exists around the explicit punch form here. And then we might work into a re-roughing operation where we're continuing to reference pre-existing cuts inside of Creo NC so that we optimize the tool path and gain the benefit of not recutting areas of the model unnecessarily. So this is an optimized path just to kind of come back in and knock down some high spots and things to that effect that would exist after the much larger roughing tool that we just watched, kind of rough that in and get that kind of cleaned up to size. And now we would see tool paths that would be coming in here and start the finishing operation on our punch. And we're kind of generating those up now. And we see the first finishing op on the punch here. We're going to use a nice combination finishing on this that uses a nice waterline approach where appropriate, and at the same time can utilize a spiral finishing if necessary over the tops of these surfaces as you see here. So like you see here in this context, we're doing a spiral finishing in this pseudo very horizontal area. These flat areas have already been dialed in by the previous tools. We know the face mill did the top of the part up here already, so that we see that that stuff's not being addressed by this machining because it's known to be already done. All right, so we're going to do some rest finishing now on the top here. So we're using multi-stage tools, so we're stepping down to smaller tools and things to that effect. So this is a big part of dealing with machining in these kind of environments where we have to use, spherical tools and things to that effect. We could come in and do some rest finishing or something like that on the top. We obviously have the ability to do the drilling and this things to that effect. We watched a little bit of that previously here when I kind of did that as a part of the associativity demonstration, if you will. whoops, I'm playing the wrong thing here. If I could turn off that calculation again. All right, so there we go. I wanted to play the center drill. So here we see, as I mentioned, that the center drill, and then of course I made those changes to the dial pin holes, and of course the center drill was automatically updated by that, and the position of the center drill drilling and the subsequent follow-ups, we'll see this in the ream and such, were altered by that dimensional change as well automatically, and I don't have any reprogramming. I just simply have to enter this file and regenerate. So as we walk through this, now we see that the reaming is also linked in on those moved holes that we see here. And of course, these hole making techniques are very easy to use. And we'll be taking a quick look at what puts a tool path together after we kind of look at the cuts that are standing up behind this part. So here we see that the big drill coming in for the counter bore and things to that effect, kind of drilling the 4 big holes out. And then here we're going to go ahead and do the counter bore itself. And here we see the counter bore tool coming in, and we're going to go counter bore those holes, and away we go. And then lastly, I've got a ream here, and that must be I must have had 2 of those in there for no good reason at all. I don't have any idea why I put 2 reams in there for the same holes. But those are our cuts in this file, and that kind of knocks our file down and gets us into a place where, you know, hey, we've got this machined, we've got this associative to Creo parametric, it's all linked in. If we make changes on the Creo parametric side, we obviously enjoy the benefits of those changes here inside of our NC space. Now, what kind of puts a tool path together inside of Creo is pretty straightforward stuff, and it arguably works very similarly to what we might see in other systems. So we open this up, and we have an array of parameters, if you will, that drive the information of cutting. So we have a feed rates are established here, as well as different stock allowances and tolerances and these step depths of cutting and things to that effect. It's very much the same as you would find in any product that is involved in NC. These are machining parameters that relate to the world of cutting, and this is where we go in Creo NC and we set them up. The beauty of Creo NC, however, is that here we get nice graphical images associated with these things, as you see here, related to step depth. It says, hey, when I select on this step depth here in my parameter array, I can see down here graphically that this is what this is how this control is going to be applied to the model. And you see here the little empty dimension, and it's kind of showing you that distinction of the bottom of the tool, and this little empty dimension. That's kind of communicating to you that, that's what it's doing. And, you see you have these tool tips, set the incremental depth of cut, things to that effect as far as that goes. And we can manipulate these things and see our changes in real time, if you will, of course, so like if we play this path back, there we see the cut path for our face mill. And if we were to subsequently activate that and change one of our parameters per se, we're going to change the angle of that face mill to 45 degrees because we can. And then we go play it back. Now we see that the face mill is tracking back and forth across the part at 45 degrees. So we can simply just address these parameters quickly and easily that way to set up and change things as we see fit. We could change our step overs. We could change our stock allowances and things to that effect right here on the fly, obviously. So I could come in here and say, hey, in terms of stock allowance, I'd like this to cut to 0 in this case. We're not going to leave any stock allowance, let's say. So now when I come back and I play this path, now we have that cut. And if I were to zoom in here, you see that the cut is absolutely now coincident with the top of the part. There is no stock allowance. It's cutting to the top of the part because that's what we set our parameters to do inside of Creo NC. The benefits of this feature is the real time, what you see is what you get kind of connectivity. So when, just as you saw here, I come in, I change my stock allowance to some value. I'll see that effect immediately as soon as I play that back in Creo NC. So now I went back and put 50,000 English of stock allowance on this, and now we see that that's where the cut is. The cut isn't even engaging the material because there isn't really that much material on this part in this case. So we can easily and quickly address and edit these parameters in order to manipulate and get our cutting to work in the way that we would prefer it to work. We can absolutely come in and make changes to influence our cutting, utilizing things like these surfaces that are exclusive that we create inside of Creo NC. These exclusive, what we call mill surfaces or manufacturing geometry is generically referred to, allow us to build on top of the design model without negatively influencing something in engineering or design and or requiring them to do it. We have these full-on capabilities and the benefits of these capabilities here inside of Creo NC. When I state that I want to make a mill surface, I have all of the power of Creo. I have a different ribbon. I can see that the ribbon is different, but I have all of the same power of creation here inside of this creation of this mill surface here in Creo NC as I would enjoy on the design side. I could utilize advanced techniques like a sweep in order to create some type of mill geometry if I need it. We'll go ahead and just whip up a quick arc in here to kind of speak to that. So there we go. I'm just going to put a piece of geometry on there and sweep it, and there we go. So it's just that easy, and I have all of that capability. I have the the sweep feature and the blending and extrude and revolve and all of the engineering surface types, fill and surfacing and blend tangent to surfaces, vertex round, etc. The things I might need from the design side are in fact available to me here in Creo NC. Now I can use something like this surface I just created to tell the tool to cut that, or I can create these types of surfaces here inside of Creo NC and enjoy the benefit of telling Creo NC not to cut that. So it gives us an enormous amount of flexibility to influence a toolpath inside of Creo NC to be exactly the thing we want in terms of creation and in our cutting workflow. So just understand that you are sitting inside of Creo NC. You are sitting on top of all of the features, benefits, and strengths of the Creo design product. And that's a lot of what makes Creo NC as strong as it does. Some of my own personal NC environment here takes advantage of things like what you see here, which is a symbol, a drawing symbol that is dynamic, and I can subsequently update data and work with that kind of live in real time. I could subsequently edit the values and parameters of these things. I could come in here to this parameters page that's associated with this symbol, and I could say, hey, I need to recalculate some values. So I need to know what a 250 tool at 225 surface footage running 4 thousandths of chip load looks like on a 4-fluted tool. So we go ahead and we say that, and I regen that. And now all of these values inside this symbol just updated to give me new information about what that would be with that 250 tool. That's gonna create a scenario where, if I was targeting that kind of surface footage on that tool, my RPM would be approximately 3,438. I'd be pushing that at about 55 inches a minute. If I was stepping over that tool 10 thousandths, I'd be leaving a scallop height of a 10th English. The effective diameter on that tool would be 0.98. The RMS value that would be calculated by those steps in that reality would be 4 thousandths. So, you can stand yourself up to take advantage of enormous power by being this intimately connected to the design side, not the least of which is to be able to use things like what I just showed here with these symbols and these features that are actually part of Creo detailing. But we just go create one of those in NC, and then we stand it up to do the things we want in NC. And it's not living on a drawing, but it's benefiting me immensely here inside of NC. And that's part of the enormous strength of Creo NC is, again, to be able to work that hand in hand with these features and these functions from the design side of the product. Creo NC obviously gets its own unique ribbon to work in, and on the mill tab in this case is where we would find the different types of cutting that are available to us here inside of Creo NC. So these are some different types of cutting and things we have. We have 3D roughing, 3D re-roughing, finishing, rest finishing, profiling, some additional volume space roughing, face milling, engraving, cut line. I mean, there's a host of different, the trajectory, milling that's path-based that I had mentioned previously. A host of different milling techniques are available to us, not to mention many of them here on the milling overflow, corner finishing, surface milling, excuse me, pocketing, pencil tracing, etc. We have a host of new advanced high-speed machining cycles available to us. High-speed machining rest finishing, high-speed machining roughing, high-speed machining rest roughing, and high-speed machining finishing as well. Those are tailored more to the organic surface machining disciplines, mold and die, things to that effect. If you will, and more sculpted organic cutting. We have a host of different hole making cycles that are available there. It's everything that everybody has all of the same drilling functionality in an NC package in the year 2024. That are typical in the hole making space. Obviously, all of those techniques are supported here inside of Creo NC. And that speaks to one of the extremely strong assets of Creo NC. Creo NC is not just a good 2D product or just a good 3D product. Creo NC is a very good holistic product. It's capable of addressing the whole part. It's not a product like Work NC that is really only focused on cutting in 3D. Or some very simple type stuff that exists, maybe a Bobcat or something like that, that's really only focused on cutting in 2D, and will in fact, fall down enormously when we try and push in some, strong 3D workflows and cutting to it. Part of the big strength of Creo NC is the ability to, in fact, work with all of this, work with all of these needs, as opposed to be only good at one or the other. Creo NC is very good at all of that stuff, and it is a very advanced system. For instance, our trajectory machining comes through 2 through 5 axis trajectory machining. We'll use this bowl tool to set that up, yes, and we'll set up our tool motions over here. We're going to do a curve cut. I'm just putting a generic cut together to show some of the really good axis control that we have inside of Creo NC. So I could pick a point on, excuse me, I picked the wrong thing here, add a location. So we're going to put that there. And then now I can graphically control the vector on this tool in 5 axis. So I can start putting tilt and, lead and lag and things to that effect.
Sean, we've lost your screen. Can you unshare and reshare?
Yeah, hold on.
We may have to stop that there, but there was a question that maybe you can answer.
Yes.
For us.
Okay. Yes. Is there a benefit to using? Yeah, I got you, Sinead. Is there a benefit to using mill surfaces over regular surfaces in manufacturing? Very good question. And the answer becomes what you need. As I demonstrated in my example, the irregular shape of the part would have given me an irregular kind of cutting result. It wouldn't have been as clean and sanitary walking down through walking down over the punch. I'm going to attempt to share my screen again. It's allowed me to try. Okay, let me know if it comes back. I'm just getting a spinning wheel here, so I apologize, but I'm trying to bring this back up again. But as I said, the benefit of using a mill surface over a regular surface being the idea of I don't want it to do what my geometry is going to give me. So I'm going to create a surface because I want to create a specific type of influence for that particular toolpath cut. Beyond your own desires to influence the toolpath, there isn't a right-wrong approach to using the surface of the model or using a mill surface. They can both be used exclusively in all cases. Anything I could theoretically, any surface of the model could be cut the same as if it was a surface, a mill surface in that space, that very much the same as I had, showed on the punch. But at the end of the day, it's the benefit of using a mill surface is to be able to influence the toolpath in a very specific way that you desire for that cut. It's not obligatory. And if you're not looking for that, I generally don't encourage users to use mill surfaces, because you do have to make the workflow, as you kind of saw for myself, in order to be able to go create that. And it is very quick and easy because we have the benefit of using all of the design power of Creo, but we ultimately still have to spend that time. So I advocate using a mill surface when there's a specific need, kind of as I demonstrated. I wanted to influence that cut on the punch, but beyond that, a mill surface is 100% optional. And that is a very good question, and thank you for it. Sinead, I don't know that I'm going to be able to recover the presentation. I keep trying while we were trading back and forth there, and it's just a non-starter.
I think we are good. Thank you so much, Sean. Appreciate it. And I appreciate all of you for attending today. If you have any questions, please reach out to us. We do have bi-weekly webinars, so check out our website for what's scheduled throughout this summer and into the fall. And if you have any questions for Sean after today, please reach out to me and we will get you connected and get the answers that you need. All right. Thanks again. Everyone enjoy your day.
Thank you.